All right, we are doing day 4 of TSI Prep. This is our last day. We're going to go over some exponentials and inequality review. So these things happen as you get further into it. As you get further into the test, typically. So first up, we have here, which of the following expression is equivalent to 20 minus 4/5 x is greater than or equal to 16. Okay, the key thing to remember with inequalities is that you're going to solve them like you are solving equations. Okay, just remember that with inequalities, key thing to remember is if you divide or multiply by a negative, the inequality changes. My pen is pretty funny. Sorry. So we have 20 minus 4/5 x is greater than or equal to 16. Okay. Remember, when you're solving, you're doing PEMDAS backwards. So I'm going to add or subtract before I multiply or divide because we're going backwards. So I'm subtracting 20 from both sides. And I'm left with negative 4/5 x is greater than or equal to negative 4. Okay, next we're going to talk about fractions. When the inverse of a fraction, or to quote unquote undo a fraction, we multiply by its reciprocal. Okay, so I'll put in parentheses and quotation marks to cancel out. I don't really want it mathematically that makes sense, but to cancel out a fraction, you multiply by its reciprocal. Okay, so you're going to multiply by its reciprocal. So the reciprocal of negative 4/5 is negative 5/4. Okay, a negative times a negative makes it a positive. 5 divided by 5 is 1. 4 divided by 4 is 1. And that's why it cancels out, because it becomes 1. It becomes invisible. Casper the friendly 1. And when I do to one side, I do to the other. So I have negative 4 over 1 times negative 5. Yeah. Let me fix that. Negative 4 over 1 times negative 5 over 4. A negative times a negative is a positive. The 4 divided by 4 is 1, and I'm just left with 5. So notice I have left with 5 divided by 1, or 5 over 1, which is just 5. So I'm going to bring down the x, but I multiplied by a negative. So my inequality is going to go from greater than to less than or equal to, and 5 over 1 is 5. So my answer is x is less than or equal to 5, which is 8. All right. Okay, so after you trying your you-do, let's check and see how you all did. Remember again, your job is to solve the inequality. So, I don't know why it's so wide. Sorry. Your job is to solve the inequality. So you want to get x by itself. So you should have subtracted 10 from both sides. And that's going to lead you to having negative 2x is greater than or equal to 10. Then you're going to divide by negative 2. Divide by negative 2. That becomes 1. Cast with a friendly 1. And we're left with x. But key thing here, we divide it by a negative. So it becomes a less than or equal to. And 10 divided by negative 2 is negative 5. There it is. All right, so this is one of the questions you would get as you are progressing and doing well on the TSI, so it's a little harder. We have rational exponent, adding, subtracting rational exponents with the same base. So the first thing we're going to do is write the exponents as mixed numbers and separate into two factors. So 5/2 as a mixed number, you're asking yourself, how many times does 2 evenly go into 5? And what's your remainder? So this becomes 2, right? And we will have 2 plus a half. That's because 2 goes into 5 evenly 2 times, and you have one remainder, okay? Minus, and then this one, 2 goes into 3 evenly 1 time, and you have a remainder of 1 plus 1/2. Okay, and then when it says separate, let me fix that 1/2. So this equals, so you have 2 squared times 2 to the 1/2 minus 2 to the 1 times 2 to the 1/2. Okay? Then you're going to factor out your rational exponents. So factoring out your rational exponents, because that's what each term has in common. So we factor out 2 to the 1/2, and we're left with 2 squared minus 2. Okay? Then we're going to simplify. So we have 2 to the 1/2 times 2 squared is 4. 4 minus 2. What is 4 minus 2? Well, 4 minus 2 is 2. So we're left with 2 to the 1/2 times 2. Then it says write as prime factor. So 2 is already a prime factor. So we just need to combine. And to combine two exponents with the same base, all you're doing is adding their powers. So you have 1/2. So you have 2 to the 1/2 plus 1. Okay? So I'm going to work this just a little bigger for us to remember, for some of us that may need to recall. If I have 1/2 plus 1 over 1, I can do the chopstick. So I have 1 times 1 is 1 plus 2 times 1 is 2 all over my bowl. 2 times 1 is 2. 1 plus 2 is 3. So 3/2. So this becomes 2 to the 3/2. Which would be C. Okay? All right. So following those same steps, you're going to do All right, so for the you do here, we give you the same numbers to work with. So you had 3 to the 3 halves. So using 3 to the 3 halves, separating this, 2 goes into 3 one time. So we're left with 3 to the 1 times 3 to the half plus, then we have 3 to the 5 halves. 2 goes into 5. I'll make my 2 too big. Let me fix that. Goes into 5 2, and we have a remainder of 1. So 3 to the 1 half. Okay, that's step 1. Step 2 is to factor out your rational. So we have 3 to the 1 half, and we're left with 3 plus 3 squared. Step 3 is to simplify. So we have 3 to the 1 half times 3 plus 9, which gives us 3 to the 1 half times 12. Step 4 is to write as primes. Well, 12. We're going to talk about 12. For 12, your prime, you have 4 times 3. Well, 3 is a prime, and 4 is 2 times 2. And 2 is a prime. So the prime factorization of 12 is 2 squared times 3 times 3 to the half. So we end up with 2 squared, and we have 3 to the 1 times 3 to the half. So 1 plus a half is 3 halves times 3 to the 3 halves. And this would be your, okay, so we talked about how these are going to get a little harder because they are further along in the TSI. That means you've done really well, you've gone through all the basics. So let's give you a little more challenge, okay? All right, on to problem 3. All right, we're on problem number 3. Problem number 3 is what we call a rational equation. Why? Because our variable that we're solving for is in the denominator. So, solving rational equations. First thing we want to do is move all terms without x to one side. So that means we're going to need to move our 1 over a. So it's a positive, so in order to move it, we're going to subtract 1 over a. So that's going to leave us with 1 over x equals 1 over b minus 1 over a. Okay, the second thing we want to do is condense each side to only one fraction. So we want to get our least common denominator. So on this side, our least common denominator would have to be a times b. Or, if you remember, we talked about chopsticks in a bowl. So when we talk about chopsticks in a bowl, so 1 over x equals, remember it says it's top to bottom from left to right, and then top to bottom from left to right, bottom to top from left to right. So we have our first chopstick, 1 times a is going to give us a minus our second chopstick, b, all in our bowl, which is ab. Chopsticks in a bowl, right? All right, so that's us condensing each side to one fraction. All right, next you're going to multiply x out the denominator. So we want to get x out of the denominator. So I'm going to multiply both sides by x. What I do to one side, I do to the other. So on my left hand, a big mistake that people make is that they say it's 0, but it's not 0. X divided by x is 1. So we're left with 1 equals, and we have x times a minus b over ab left on the right side. Okay. Third, we're going to use inverse operations to isolate x. So this is a fraction. Inverse of a fraction is to multiply by its reciprocal. Okay. So we're multiplying by the reciprocal. So we're going to multiply by a over b times a minus b. And what we do to one side, we have to do to the other. So we get a over b, a minus b. And so therefore, once this is done, eliminate, eliminate, and we're left with x equals anything times 1 is itself. A times B over A minus B. So therefore our answer would be E. All right. Questions, comments, concerns? If not, then let's keep it going. So here's yours. Well, let's see how you guys did. So, same thing here, except this time you're adding, right? So all you did was add. Step one was move all terms without x to one side. So you should have added 1 over a. So now you have 1 over x equals 1 over b plus 1 over a. Then condense each side to only one fraction. So using our chopsticks, that gives us 1 times a is a plus b times 1 is b, bold, a times b. Multiply by x to get it out of the denominator. We do to one side, we do to the other. X divided by x is 1, not 0. So we're left with 1 equals x times a plus b over ab. Use inverse operations. The inverse of a fraction is to multiply by its reciprocal. So we multiply both sides by ab over a plus b. And what we do to one side, we do to the other side. And so we get x equals ab over a plus b. Okay, yes, I know it's pretty straightforward because all we did was go from subtraction to addition. So, all right. Number four says the graph of each of the following equations is a straight line parallel to the graph y equals 2x. The graph of which of the following? So things we need to recall is that parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. That means one is positive, one is negative, and we flipped slash switch the numerator and denominator, right? So to find slope in standard form, the fastest way is to solve for y equals, and write it in y equals mx plus b, and image your slope. However, because this problem, oh yeah, that's right, it's over here. I was on the wrong problem in my mind. So we're going to quickly isolate y. So when we're looking here at 4x minus y equals 4, if I want to get y by itself, I'm going to have to subtract 4x and then divide by negative 1. Because remember, minus something means that you are adding a negative 1. Negative 1, negative 1, negative 1. Okay? So hopefully you all see that. So for A, we're subtracting, so we have negative 1y equals, and we subtracted 4x, negative 4x plus 4, because it was a positive 4. We divide by negative 1, divide by negative 1, divide by negative 1, and we get y equals 4x minus 4. Okay, our slope here is 2. And this slope is 4, so we know that it cannot be that one. Okay, what we also should notice here is that when we divided by negative, it made our slope a positive. And so we know that we have to be able to divide by negative, and d is a plus. So we won't be dividing by negative, we will be dividing by positive 1. So we can eliminate d as well. So let's test b. So we have b, and that's 2x minus 2y equals 2. So we're going to subtract 2x, and we're left with negative 2y equals negative 2x plus 2. Then we divide by negative 2, divide by negative 2, divide by negative 2. And that leaves us with y equals x minus 2. And oh no, I didn't need that. Okay, we're trying to get 2, and we had to divide by 2, and that did not work. So couldn't be B. So let's test C. So we have 2x minus 1y equals 4. So we're subtracting 2x, left with negative 1y equals negative 2x plus 4. Divide by negative 1, divide by negative 1, divide by negative 1. Positive 1. So y equals positive 2x minus 4. Oh look, our m is 2. Yay! So our answer has to be C. Okay, so that is one way of doing it. What I want to focus on is our is the fact that we're in standard form. And so when you're in standard form, so these are all in standard form. Remember, standard form is ax plus by equals c. This is the standard form of a line. And so in standard form, you actually can find the slope by using its own formula. So the slope in standard form is n equals negative a divided by b. So it's your negative a divided by b. Just means that the opposite of what a is divided by your b value. So for example, we know the answer is c, right? So if we look at c, the a for c is 2, the b for c is negative 1, right? So therefore our slope would equal negative 2 divided by negative 1, and we get positive 2, okay? This we do not commonly memorize currently in Algebra 2, not Algebra 2, in Algebra 1, I mean. And so a lot of times it's hard for people to remember that in standard form, there is a separate slope formula, which is n equals negative a over b. And in this situation, it would go fairly quickly. What you guys do focus on a lot is just solving for y and getting y by itself. And that's why I reiterated that and went through this here. But there is another way, which is utilizing standard form and finding the slope from there. All right. Okay. Here's yours to do. So it's pretty easy. Everyone's answer is going to vary. It's just making sure you're understanding the vocabulary. So it says write an equation with in y equals mx plus b form that has the same slope as y equals 4x plus 5. So you're trying to create a parallel line. But yeah, so yours can be anything. It's going to vary from person to person. Possible A possible thing that you could have written is you could have wrote y equals 4x plus 100. Why? Because it's the same slope. And what is my slope? My slope is m. Is my slope is m, which is 4? And is this still 4? Why, yes, it is. So you could have written y equals 4x minus 2.21. Whatever made your heart happy, as long as your slope is 4. All right, here we have an equation, a line that contains the origin and the point 1, 2. The fact that you're at the origin makes this so much easier. You're at 0, 0. And when working with zeros mathematically, oh my gosh, it tends to make things a lot easier. So an equation of a line that contains the origin and the points 1, 2 is, so remembering this, linear equation given 2 points, your first thing that you're going to do is find the slope using the slope formula. Okay, your y2 minus your y1 over your x2 minus your x1. Your points are labeled, or you think about it. Here's your first set of points that were given to you, and here are your second set of points that were given to you. And they're just plugging those values in. So we have 2 minus 0, m equals, over 1 minus 0. So therefore our slope equals 2. Okay? Then it says find the y-intercept. Well, your y-intercept is always 0, comma b. If we didn't have 0, comma b, then we would be looking for, we would use y equals mx plus b to substitute and solve for it. But we're at the origin. So if we're at 0, 0, that means that our b is 0. So then we plug into the equation. So we plug into the equation. We have our m, we have our b. So we know that y equals 2x plus 0. And it's kind of redundant to write plus 0. So it would be answer choice A. Okay. So here is yours. Let's check to see how you all did. So you had origin again. So at the origin, 0, 0, right? So we found the slope, our first point given, our second point given. So we have 7 minus 0 over 3 minus 0, which gives us 7/3. Because you're at the origin, remember that means that your b is, and then you plug into the equation, so we should have gotten y equals 7/3 x. Okay, let me know if you have any questions, comments, or concerns. Here we have log base 10x equals 3. This is called our common log because the base is 10 and it wants to solve for x. So solving common log equations, you're going to rewrite the log as an exponential equation. We talked about this being log base bx equals y. So think about with log, it's alphabetical order, bxy. And then for exponential equation, say by to your x, okay? By to your x, that's how you convert it. What's your b? What's your y? What's your x? By to your x, okay? So we have log 10x equals 3. And therefore this is our b, this is our x, this is our y. So as an exponential, we are going to say by to our x. So our b is 10, our y is 3 to our x. So by b to the y equals x. Okay? Then simplify and evaluate. Well, 10 to the third means that you have 10 times 10 times 10. That's what x equals. 10 times 10 is 100. 100 times 10 is 1,000. So our answer is B, 1,000. All right, your turn. So you have log base 2 to the x equals 4. Then you're going to solve for x. Remembering here, by our x, go through the steps. Let's see how you all did. So the first thing we're going to do is rewrite. So this was our b, our x, our y. So we're going to say by to our x. So we have b, which is 2, to the y, which is 4, equals x. Then we evaluate 2 to the 4th, and we show 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So your answer should have been 16. Alright, good job. 7, we are talking about composition of functions. Okay? Why is it composition of function? Because when I look at this, it says if f of x equals 2x plus 1 and g of x equals x minus 1 over 2, then f of g of x, so f composed of g of x equals. Okay? The first thing we're going to do is understand that composition of function means to substitute another function in for x rather than a numerical value. Okay? So write in the function notation. So we're currently at f of g of x. So f of g of x means that I'm taking whatever g of x equals and I'm substituting it into f. So g of x equals x minus 1 over 2. So that gives us f of x minus 1 over 2. So that's what we're going to do. So what used to just be x is now x minus 1 over 2. So that where x is, we're now putting that. So we have 2 times x minus 1 over 2 plus 1. Then we're going to simplify. Okay? 2 divided by 2 is 1. So they disappear. Become cast with a friendly 1. And we're left with x minus 1 plus 1. Well, negative 1 plus 1 is 0. And we're just left with x. So the answer is A. So those are the 3 steps that you're going to follow. Okay? All right. try this one, please? Thank you. All right, let's see how you all did. So again, first thing is write in function notation. So writing in function notation this time, you are composing f of x into g. So we have whatever f of x, which is 2x. So you should have g 2x, right? Now we're going to substitute 2x in to wherever x is in x squared. So that gives us 2x, oh that's weird looking 2x squared, right? Then we're going to simplify this. So 2x squared, we're going to distribute the power. So we have 2 squared times x squared, which equals 4x squared. Good job. All right, last but not least, if the two square regions in the figure below have the respective areas indicated in the square yards, how many yards of fencing are needed to enclose the two regions? Okay, so geometry review. Things to remember: area of the square equals s squared. Perimeter of the square is 4s. Okay, so steps that we're going to follow: find s, so the side of each square. All right, it tells us that this number in the middle, that's the area. This guy right here is the area. So we can use the area to find the side of our square. Okay, we're going to call this side S1, and we'll call the big guy S2. So for the little guy, 5, so area equals 5, and 5 equals S squared. To find S, I know it's kind of weird to have this is an S. 2's, S's, and 5's. Can't be fun. I'm going to try to emphasize that this is a 5. I hope you can clearly see my attempt to be distinctive between my 5's, my S's, and my 2's. Yeah, let's not use S's. Let's switch them to X's. Just for the sake of our sanity, we're going to switch our S's to X's because they're unknown, right? Anyway, so we're going to use also can equal x squared and 4x. So we'll let this one be x1 and this one be x2. I think that'll be so much better. So we have 5 equals x1 squared. Okay? So if we're looking for just x, not x squared, we're going to take the square root. If I take the square root, what I do to one side, I have to do to the other. So now I know that x1 equals square root of 5. I'm going to do the same thing with my larger. We know that area equals 125. Area is x squared. So we're going to take the square root. Now, 125 isn't a perfect square, but also 125 can be simplified. So 125 breaks down to be 25 times 5. I can take the square root of 25, not 5. So the square root of 25 is 5. So we have x2 equals 5 square root of 5. Okay, So we now know the side of each one. So this little guy is square root of 5. This little guy is 5 square root of 5. All right, find the perimeter of each square. So find the perimeter. So perimeter of the little square equals 4 times x. Well, what do we get for our x? Square root of 5. So this is 4 times square root of 5. Perimeter 2. Again, you're doing 4 times x. This time, our x is 5 square root of 5. So we have 4 times 5. 4 times 5 square root of 5, which equals 4 times 5 is 20. 20 square root of 5. Okay? Not because the problem asks for how many yards of fencing are needed to enclose the 2 regions. So we're going to add the perimeters to find the total. So we're doing P1 plus P2, which equals 4 square root of 5 plus 20 square root of 5. When you're adding radicals, you're only adding the values outside of the square roots as long as the values inside the square roots are the same. So we're just adding 4 plus 20, which is 24. So we have 24 square root of 5. And this is our exact value. So this would be a multiple choice, and you choose one that's at 24 square root of 5. Excuse me. All right. Ignore the fact that this is you do problem 7. This is you do problem 8. All right. So if the 2 square regions in the figures below have the respective areas indicated in the square in yards, how many yards fits are needed to enclose the 2 regions? So you have a small square of 4 square yards, and you have a large square of 100 square yards. And you're going to go through what we did to find the perimeter. All right, let's see how you did again. Let's say 8. So finding S. So finding S for this one. We have our area. So we'll look for x1 here and x2 here. So we have area, which is 4 equals x1 squared. So I'm going to take the square root. So we get x1 equals 2. So we know that each one of our sides equals 2. Then we have 100 equals x2 squared. We're going to take the square root of both sides. Gives us 10 equals x2. So we know that each side is 10. Then we're going to find the perimeter. So the perimeter of the first square equals 2 times 4, which is 8. Perimeter of the second square equals 10 times 4, which is 40. We're going to add the perimeters together to find the total. So that gives us 8 plus 40 equals 48 square yards. Not squares, yards. Because it's perimeter, not area. And that concludes your day 4. So please work on your classwork and do your best to complete it, and be prepared to take your quiz tomorrow. which is a mini version of the TSI. Thank you.